Welcome to Activity 3.3, Complex Systems That Begin Moving. So for today's activity, it's going to be self-paced. There's going to be times where you're going to have to check your answers with your teacher. There's going to be times that you have to check your answers with an answer key. But the goal for this activity is to have it completely done by the end of the hour. So complete all of Activity 3.3. And if you're good and your team is working hard, you may even have 10 to 15 minutes to study for the test or finish up some of the missing work that you may have or work on the check for understandings. So the learning target today is we're going to begin to explore, we're not going to begin, we're going to continue to explore how devices begin to move in the directions they do. So if you remember back to the beginning of this book, you went around the room, you rotated around the room. There was 4 different stations set up. There was the magnetic cannon, the air-powered car, the floating magnet, and the flying balloon. We're going to revisit each of those stations. Now, you're not going to be going to the stations and redoing the activities, but we're going to revisit the scenarios. And if we remember earlier, for activity 2.4, you were given a sheet of paper, and on those were the model, and we had to work out all the forces that were happening in each of those models. So one, you're going to want to have that diagram. That piece of paper will help you finish activity 3.2, or 3.3, sorry. So if you could open up your books to page 34. So if I'm going to have to change this to 34 because the book changed this here. So open up your books to page 34. Here are the procedures. You will not have time to construct free body diagrams for all 4 apparatuses in class. Your teacher will tell you which one or 2 to work on first. Then you will finish working on the others as homework. Now here's the good part. You don't have to do this as homework. I'm going to give you the entire class period to get this done. So instead of just giving you 10 to 15 minutes and saying, okay, do this one here, do this one, and then finish the rest up at home, you're going to have time to do it all here in class. Now again, in lesson 2, you constructed models that represented these apparatuses and their interactions with their surroundings. Use these models to help you construct a free body diagram, to help you figure out which parts of the systems described in your models you need to focus on. Here are a few hints. So again, pull out that sheet of paper. If you're not sure what sheet of paper it is, come ask. But it's the one where we drew in all the models for the magnetic cannon, the flying balloon, the air-powered car, and the floating magnet. So when we look at number 1 on page 34, it says, well, it's not number 1, it's A. In the floating magnets, explain why the upper magnet floats. Draw a free body diagram to explain. So if you look in your book forgot to mention this last part where you have to draw a free body diagram. But here's their hint. In the floating magnets, explain why the upper magnet floats. So in other words, you're going to draw a free body diagram for the upper magnet. So go ahead, look at your sheet from activity 2.4. Look at just the upper magnet. What forces are acting on the upper magnet? So you should have the upper magnet, you should have the lower magnet, you should have the earth, gravity, and weight. So on the upper magnet, what forces act on the upper magnet? So go ahead, practice drawing a free body diagram. You can pause the video now. When your team has drawn the free body diagram, you can start the video again and go on to B. So go ahead, pause now. All right, so you've had a chance to draw the first one. So in the second one, in the magnetic cannon, explain why the last ball begins moving. Draw a free body diagram to explain. So look at the magnetic cannon's force model. So it's the full model. What forces are acting on ball E? Because you remember ball E shot out. What forces are acting on it? What forces cause ball E to fly out? So you can start by drawing ball E. So draw a circle and label it ball E, and then go ahead and put all the forces that act on ball E in your free body diagram. Make sure that forces that act at a distance are dashed. Make sure that contact forces are solid. And make sure you label each arrow. You don't have to have other squares and rectangles, but you do need to label each arrow. Make sure you have it correctly on here. Make sure horizontal forces are horizontal and vertical forces are vertical. So go ahead, pause the video, and complete this with your team. Once you've completed it with your team, go ahead and unpause the video. So go ahead, pause now. All right, so you've had 2 chances to practice drawing free body diagrams. So go ahead and do C. In the air-powered car, think of the car and the fan as a single object to figure out why it starts moving horizontally. Draw a free body diagram to explain. So this is a little bit different than what we've done. Here it says, if we read it again, think of the car and the fan as a single object. So when you draw the square in here for a free body diagram, we're going to think of the car and the fan as a single object. Why? Well, we taped it together. It was all part of one. So so treat it as one. And then take a look at what forces in your diagram acted on this part. In other words, what forces caused the car to move. So go ahead and pause the video. When you get done with your free body diagram, unpause the video. And finally, letter D. This is your last free body diagram. So you should be on page 35 now. In the flying balloon, treat the balloon and the straw as a single component to explain why it starts moving along the thread. Again, you tape the straw to the balloon, so we're going to treat it as one. So go ahead, draw that rectangle, and you can label the rectangle balloon/straw. And look at your force model, the full model. What forces acted on the balloon/straw? Label all these. You don't have to pause the video. The video will be ending soon. But what I do want you to do is once you write down the scientific principles, I want you to bring your models up. So the whole team should come up. Your teacher is going to briefly look them over. And if you did a good job with your models, you're going to be able to move on. If not, you're going to have to sit down and work on them again. So the more time and effort you put into your models, the better chance are that you're going to be able to move on. So record these scientific principles in your book. Number 5, forces that are applied to an object in opposite directions counteract each other. And forces that are applied to an object in the same direction reinforce one another. So once you have these written down, bring part 1 up to your teacher. If it's approved, you're going to move on. And this will end the video. Make sure you ask questions if you have them.